Hello, and welcome to the video on how to find a linear approximation of the function f of x equals the cubed root of x when x is equal to -64. Now remember, when we are looking at finding the linear approximation equation of a function, we're really just finding the equation of the tangent line to that function at that x value. In order to do this, we want to remember that our derivative is the formula that gives us the slope of the tangent to a curve at any point. So if we find the derivative and evaluate it at our x value, that's the slope of the tangent line there. So the first thing we want to do when we're finding this linear approximation is to find the derivative of the function. So our function is f of x is equal to the cubed root of x. But in order to take the derivative, we're going to write that cubed root of x as x to its fractional exponent 1/3, which means the same thing as the cubed root of x. Next, we are going to apply our power rule. So our derivative f prime of x is, well, remember, if we have letter base to number power, we bring the number power as a factor in front, keep the base, and subtract 1 from the exponent. 1/3 subtract 1 is a -2/3. Now, because we are going to evaluate this derivative at x equal -64, we have to get it in the form that it's easier to evaluate when we plug in a number. So we want to make sure we first write it without a negative exponent. So f prime of x is 1 over 3 times x to the 2/3 power. When we write it in the other part of the fraction, it changes the sign of the exponent. And then we also want to write it as the radical notation. So again, it's just a little bit easier to think through the simplification when we plug in a value for x. So this is 1 over 3 times, well, the denominator of 3 in the exponent on the base of x means the cube root of x, and then the numerator is our exponent that we take it to. Many times when we write it in a simplified form, we would write it as 1 over 3 times the cubed root of x squared, and the square would be on the x under the radical. But when we want to plug a number in for it, so that our values don't get too large for us to be able to work with easily, we want to find our root first and then take it to the power. So now let's look at our f prime evaluated at our x value of -64. So that's 1 over 3 times the cubed root of -64, and then close the parentheses and square that. So our f prime of -64 is equal to 1 over 3 times, open our parentheses, the cubed root of -64 is -4, and then we still have to square that. Following order of operations, our f prime of -64 is 1 over 3 times, well, -4 quantity squared is a 16. So that gives me f prime of -64 is 1 over, and 3 times 16 is 48. So that's the slope of our tangent line at x equal -64. Now we want to form our linear approximation. And our linear approximation, L of x, is equal to, it's f of a plus f prime at a times a quantity x minus a. Now the a that we're talking about here is the x value that we are finding our linear approximation at. So a is -64. Now we're going to see what we can do for our replacements. We just calculated our f prime at -64, and we're going to recall that f prime at -64 came out to be 1 over 48. Our f of the negative 64 is equal to, look at your function, follow your notation. The function is the cubed root of x. So that's the cubed root of negative 64, which gives us negative 4. And then our a value is negative 64. So we're ready to plug everything in. Our linear approximation L of x is equal to f of a, so f of negative 64 is negative 4, plus f prime of a, the f prime of negative 64. So we have our f prime of a we're doing now. That's f prime of negative 64 is 1 over 48. And then open parentheses times x minus, and then minus our a, and our a is negative 64. So there is just a little bit more that we want to simplify, but we don't want to simplify too much. So we will go ahead and take care of that double negative. L of x is equal to negative 4 plus 1 over 48 times x minus a negative 64 is x plus 64. And that's as far as we want to go with our simplification, because we want to remember that if we use this linear approximation to approximate for an x value output of this function using the linearization, we need to make sure we only do it for x's that are close to the x values that we created the linear approximation equation, the tangent line. And so I want to make sure I only use this one for x values that are close to negative 64. And by leaving these parentheses and not actually distributing the 1 over 48 and collecting like terms, we are giving a visual reminder to only use this linearization to approximate the cubed root of the value for values that are close to negative 64. Well, thank you for listening today, and I hope you've found this video helpful in the process of finding a linear approximation of a function when you have a specific x value.